So this is Algebra 1, Semester 1. It's a unit called Graphing Linears. It's the third unit, and it's a lesson called Graphing Linears and Slope-Intercept Form Practice. It's lesson number 9. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Typically, I try to model for you how to find these notes because they can be difficult for students. So let's see what we've got. Here's the actual name of the website, creatormath.weebly.com. If you type that into Google, hopefully you will find a homepage that looks like this. Okay, that's how you know you're on the right site. If you have any questions about the composition book, which is a big part of the class and provides the notes for the practice set we're about to do, scroll down on that home page until you find composition book. Read the directions, you guys. Watch all the videos. Adhere to the turn-in dates and put everything on the pages in the places it belongs. All right, including the notes, which we're going to go to now. For the actual video we're making, all right? And this may or may not fit with you, so just make sure you're watching the right video and the right semester. Under the tab of the class that you're in, you will find 5 things at least. You will find the page numbers on which the notes go in the composition book. You will find the notes themselves. You will find the practice problem set, which we're going to do one right now, and you will find a copy of this video we're making right now. Of course, you will also find the PDF of all the vocabulary we will use through the entire school year. So if you're not getting 100% on your vocabulary practices, maybe you don't realize there's a PDF of all the vocabulary we use. Make sure you download this to your device. Google how do I search a PDF with the device you're using and follow the directions. Each device is a little bit different. Scrolling down now, we're going to go to the semester for this video and make sure you're matching up the right semester for the class you're in. So in this case, this is for the video we're making right now. This is the all-important table of contents. It should be written in completeness, in totality, on page 2 through 6 of your composition book. Why is it so important to me? It takes up 3.5 pages and takes you 30-40 minutes because you do it once for the semester, and now you know what page everything goes on in your composition book. Please make sure you're watching the Google video or watching the YouTube video on how to number the pages of your comp book. So that's done correctly, so everything is in the right place. That way, when I grade your composition book, and I have to grade a boatload of them every 4 or 5 times a semester, right? At least I can go to the right page, find the right thing, and give you credit for it. All right, so with that said, now we're going to find the unit that we're talking about here. This one is not equations or inequalities. It is graphing linears. And it happens to be lesson 9. So these are all the lesson numbers here. Let's go to lesson 9. It says graphing linears and slope-intercept form. That matches the title that we read already. Here are the pages in your comp book on which the notes go. Please don't take this video's word for it, but go back and find the original table of contents. At the time you're viewing this, these page numbers probably, most likely, maybe will have changed. Here are the notes we're going to look at here in a second that go on these pages. The problem set is the one we're looking at here, and this video will be linked here to video solutions if everything goes as planned. So now we're going to open the notes. Fair warning, it can take me a couple of times to open this, depending on my device and my internet, and I'm not sure what, maybe my device flash memory or something. I got no idea, you guys. So make sure you can expand it. These notes will go into your composition book to give you an understanding of what we're dealing with. This is talking about the slope-intercept form of the equation is y equals mx plus b, the all-famous y equals mx plus b. There's a y and an x because we have an x and a y-axis on the Cartesian coordinate graphing system. We have an m, which is a slope, and we have a b, which is a y-intercept. So the slope m equals the slope is rise over run, also known as delta y over delta x, also known as y2 minus y1 over x2 minus x1. And at this point in the semester, you've done a lot of different lessons on graphing and on slope and the y-intercept and on the slope-intercept form, but this is just yet another one explaining graphing in slope-intercept form. So the b in this y equals mx plus b is the y-intercept. All right, example. There's examples on how to graph if it's y equals 3x plus 2. We're going to go to the 2 first. We go to the y-intercept first. And I just tell students go in alphabetical order. B is in alphabetical order before m, so do the b first. So y equals mx plus b. We're going to do the 2 first. Starting at the 2, we're going to do the slope, which is rise over run, 3 over 1. Up 1, 2, 3 over 1, put 2 points, now draw, and that's going to create a line or a graph. If it's -2, we go down to -2 first, and if it's 3, we go up 3 over 1. So 1, 2, 3, and then over 1, put another point, draw the line between them. If it's -1, we start here, and if it's a -2, it's -2 over 1, or down 1, 2 over 1. So in that case, it's a negative slope. Anything up to the right is a positive slope. Anything down to the right is a negative slope. Okay, maybe you twist it this way to see it's going down to the right. Don't forget Desmos.com, which we've used a lot at this point. Don't forget that a horizontal line has 0 slope, a vertical line has an infinite slope. Some of the vocabulary: y-intercept, y-axis, slope equals rise over run, etc. Make sure that's all in your comp book. That'll help you answer the problems for this problem set. Here we go. What's the definition of slope? More than one answer may apply. Well, it's rise over run. Well, it is y2 minus y1 divided by x2 minus x1. That's true. It's also delta y over delta x. That means y2 over minus y1 over x2 minus x1. That's what delta means. Delta means change in. So you read it like this. Instead of delta y, you say change in y divided by change in x. Okay? And that's what delta means. It is a Greek letter D, and we do use it to mean change in. So this is correct. It is the symbol is M. I say the word mountain because that's like walking up a mountain, right? Here's my little stick figure. That's what slope is. It's the slope or steepness of walking up a mountain, or it could be walking down a mountain. So M means mountain. I don't know if that's actually true. I just made it up, okay? So that's what I tell students. It helps me remember. Change in y over change in x. That's the same thing as delta y over delta x, just spelled out in words. All right, so all of these are correct answers of what is the definition of slope. Number 2, which is the y-axis in the Cartesian coordinate plane? Well, that's a good question because students will sometimes ask, which axis is which? It's always horizontal is x, vertical is y. So the y-axis is the vertical number line. Okay, this is a number line here, vertical, right, up and down. Horizontal is left and right, or like looking out at the horizon. So these are two number lines, a horizontal number line and a vertical. The y-axis is the vertical number line. Okay. What is the y-intercept? It's where the graph crosses the y-axis. So on this thing, where does the graph cross the y-axis? Right there. That would be the y-intercept. Intercept means to cross. And I think of football where an interception is where the path of the ball and the path of the opposition player cross. Right? That's what an interception is to me. And that's where y-intercept allows my brain to remember. That's where the graph crosses the y-axis. What is the equation y equals mx plus b called? Y equals mx plus b is called the slope-intercept equation of a line. Why, you guys? Well, because it's got the slope in it and it's got the intercept. So it's called the slope-intercept equation of a line. When I finally realized that, and just to be perfectly honest with you, it probably wasn't until college that I realized that. But it became clear to me why this whole y equals mx plus b. I started to get it. Oh, there's a slope and an intercept. It's called the slope-intercept form of the equation of a line. Okay. In the equation y equals mx plus b, what's the m? The m is the slope, rise over run, right here. Okay, piece of cake so far. They're just sort of giving us foundational items here. In the equation y equals mx plus b, what's the b? It's the y-intercept. Okay, that's where the line crosses the y-axis. When graphing the equation y equals mx plus b, what do you do first? Go alphabetical, do the b. Okay, do the y-intercept, which is b. All right, so it says b, comma, the y-intercept. Okay, that's what you graph first. Remember, the x is an axis and the y is the axis. So the only two things you're graphing are the b and the m. And to go with b, because it's alphabetically first before m. What's an easy way to remember b first? B comes first before M in the alphabet. Y and X remain because they represent the X and Y axis. That's what I just said, and there it is. Which equation would be another way to understand the slope-intercept equation of a line? So yeah, this is interesting. Y-axis equals slope times x-axis plus y-intercept. So look at y equals mx plus b. This is x-axis, this is y-axis. X-axis, y-axis. This is slope, and this is y-intercept. So if you had to write out the whole thing, y equals mx plus b, I argue you'd write y-axis equals slope times x-axis plus y-intercept. Now, why don't math teachers do that for students? Because we get so bored with just long things. We love to make it so efficient. Y equals mx plus b. And that's said with a little bit of sarcasm, because in so doing, we confuse the craziness out of students, okay? So there's an advantage to the beautiful simplicity, right? And that's what, the way math people start to talk, we just look at how elegant this is. That's really a word. I can't spell elegant, but I know what it means. It means, wow, this is simple and beautiful, and it represents so many things within it. But it might be better to write it this way, just so students can get an understanding of what all is involved in y equals mx plus b. Anyway, up to you. I'm not going to change the profession. I'm just going to propose that you consider it. When graphing y equals 3x plus 2, what do we graph first? You're going to graph the plus 2 because that's the b, the y-intercept. Okay, when graphing y equals 3x plus 2, we have to first put the point plus 2 on the y-axis. Then what do? Starting at that point, starting at the point plus 2, we count up 3 and over to the right 1 and put another dot. Okay, let's see, do they actually have us do some of these? I think they do. Let's see what they do. What is the least number of points we need to plot before we can draw a line? The answer is 2, you guys. When students first learn to graph, they start plotting all kinds of points. Later, as you get into high school, I don't want you to graph that many points. Just put 2 on a graph and go from there. And let's just try it. Let's run this through given this example. All right, so look, we've got y equals 3x plus 2. Let's do a quick graph. We're going to start with the b, 1, 2, put a point. That's the y-intercept. We graph b first, plus 2, right? Then we go to the slope, 3 over 1. 1, 2, 3 over 1. Put another point. How many points do I got on the graph? 2. Guess what I can do? Draw a graph. I'm done. This is the graph of the equation y equals 3x plus 2. I don't need to plot out a bunch of points. I do need to check it, right? We're always going to tell students to start to expand your technical understanding. Pull up Desmos.com. You should do this regularly. Have it as an app on your phone, or I just have it, logged into my internet tab there, and type in y equals 3x plus 2. 3x plus 2. Aww. There it is. Notice where it's crossing the y-axis. We're going to click on this at 0, 2. So sure enough, this is at 2 right here. Right? That is the y-intercept. And then notice the slope. 1, 2, 3, up over 1. Rise over run, up 3 over 1. AM equal to 3 is equal to 3 over 1, which is equal to rise 3, run 1. All right, let's go through another one. Given the graph y equals negative 2x plus 1, what do we graph first? Do the negative 1. Okay, it's the y-intercept. Given the graph, the same thing. If we have first put the negative 1 on the y-axis, what do we do next? Starting at the negative 1, we count down 2 over 1 to the right and put another dot. Why did you go down 2 this time, you guys? We count down 2 because it's negative, right? So you go down 2 over 1. It's still rise over run, but a negative tells you not to rise, but to go down. When graphing, okay, we're switching to another one. So let's do this one quickly. Let's give it some space here. Okay, let's do a quick negative 1. So start there first. This is negative 1 on the graph. Now go down 2 over 1. 1, 2 over 1. Down 1, 2 over 1. Put a second point. How many points you need to draw a line? And I'm going to move my paper a little so I can try to draw a straight line. All right, that's it. This is the graph of y equals negative 2x minus 1. How do we check it? Y equals, let's put a negative 2x here, so negative 2, so negative 2x, and we had a minus 1, minus 1. There we go. And let's expand it a little. I'm trying to. Here we go. And there's where it crosses right there at negative 1, just like we did. See our negative 1? And we go down. Let's get our scale a little bit more understandable. Go down 1, 2 over 1. So down 1, 2 over 1. So sure enough, our quick sketch is every bit as good. Well, maybe not every bit as good as Desmos, but you can clearly sketch a graph quickly on your paper as long as you understand the y equals mx plus b components. Third one, when graphing y equals negative 1/3 x plus 2, what do we graph first? Do the plus 2, okay? When graphing negative y equals negative 1/3 x plus 2, if we have first put the plus 2 on the y-axis, what do we do? Starting at the plus 2, we count down 1 and over 3 and put another dot. Okay, let's do it for you so you can see quickly, and then we'll jump on. Okay, we'll do it for you quickly, and then we'll jump on Desmos and prove it, right? So draw a quick graph. Plus 2. 1, 2. Here. That's the y-intercept. There we go. Got it. I don't need to label 1, 2. You can just clearly see 1, 2, right? Negative 1 over 3 is the slope. So down 1, right? And if we write it this way, maybe it's easier for your brain to see. Down 1 over 3. 1, 2, 3. Down 1 over 3 and put a dot or plot a point with 2 points, trying to get as accurate as I can here. It's not perfect, but there we go. There's my graph of y equals negative 1/3 x plus 2. How do we prove it? Let's go to our technology and let's practice it right here. All right, so negative 1/3 x. We've got a negative in there already. Let's put a 1 divided by 3, so negative 1/3 x, and it was plus 2 in this case. Change this to plus 2, okay, and pull this down where we can see it, right? Where is it crossing? Right through the 2 on the y, just like ours is, and the slope is down 1 over 1, 2, 3. Notice it right there, all right? Practice it a little bit, you guys. Even with 3 examples here, you should be able to graph quickly and easily and prove it on Desmos, and now you're graphing with the slope-intercept form of the equation of a line. Make sure you are matching up the title of this video with the practice set you're doing. It's Algebra 1, Semester 1. Unit is Graphing Linears, number 3, and the lesson is Graphing Linears and Slope-Intercept Form Practice, number 9. And it's on creatormath.com under the Algebra 1 tab. Hope this helps.